Hi friends, this video is on motion of physics, part 11 of 14 numericals. This video is brought to you by COACHINGCARES.IN, designing future by smart education. In this lesson, we are going to study some numericals. This is problem number 6. Under this problem, a motor car decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. So let us note it down the data. Let us say the initial speed is u, which is equal to 80 km per hour, and the final velocity is v, which is 60 km per hour, and the time is taken t is equal to 5 seconds. So we'll calculate acceleration, which is equal to final velocity minus initial velocity by t, which is nothing but 60 minus 80 divided by 5 minus 20 by 5, which is nothing but 4 meter per second square. This is the acceleration of this motor car. So acceleration is in negative. So you have to remember this. So this is called negative acceleration. Or we can say this is a retardation. Under retardation or negative acceleration, speed decreases, so acceleration is in negative direction. Now let us take another problem. That is a truck starting from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find out the acceleration. So truck is rest at initial position, so its initial velocity, say u is equal to 0, v is given 40 kilometers per hour, and time t is given 10 minutes. So we can convert it to r, that is nothing but this much of r. So acceleration will be equal to v minus u divided by t, which is nothing but 40 minus 0 divided by 1 oblique 6, that is nothing but 40 into 6, that is nothing but 240, and that is kilometer per hour square. So that will be the acceleration in kilometer per hour square. If you want to calculate the same thing in meter per second square, we'll convert this time in seconds, and we'll convert this 40 kilometers per hour into meter per second, which will be equal to 40 into 1000, 60 into 60. So that will be equal to 400 divided by 36. That will be meter per second. And like this we can convert 10 minutes in seconds. That will be 10 into 60. That will be in seconds. And in that case, acceleration will be equal to v is what? V is now 400 divided by 36 minus u, that is 0, the whole is t is 10 into 60, that is in seconds, so that will be 600. That thing will become 400 into 600 divided by 36, and like this you can calculate. That answer will become meter per second square. So like this you can calculate in different units all the answers and you can get it. So if you want to solve, you can solve it. That is 24. You can cut it. That is 100 like this. So that will become like 40,000 divided by 6. So that will be something 6.67. That will be in meter per second square. So like this you can solve the problems. Let us take another problem. Starting from the stationary position, Ravi pedals his bicycle to attain the velocity of 6 meter per second in 30 seconds. Then apply brakes. Applying brakes means there is a retardation, negative acceleration, such that the velocity of bicycle comes down to 4 meter per second. That is case 2 after applying the brakes. That comes in 5 seconds. So calculate the acceleration of the bicycle in both the cases. Let us take case 1. Initial velocity of bicycle is u is equal to 0, v is equal to 6 meter per second, t is equal to 30 second. So by this we can calculate the acceleration is equal to v minus u divided by t, which is 6 minus 0 divided by 30. So this will be 0.2, that will be meter per second square. This is the acceleration case 1. Let us take case 2. In this, u will become the speed that it attains, that is 6 meter per second. V will become, it attains the, after applying the brakes, it gets, the speed comes down to 4 meter per second. So this is 4 meter per second, per second, and time that comes down to 4 meter per second is 5 second, that is 5 second. By this we'll get the acceleration. In the same formula we'll put v minus u divided by t. So that will be v is 4 minus 6 divided by 5, which is nothing but minus 2 divided by 5. So that will become minus 0.4 meter per second square. So like this you can calculate in both the cases and the acceleration in meter per second square. This is called retardation. Okay. So now let us take another problem. That is the basically interpretation of the graph. So you can visualize this graph. I just draw one graph here. So graph is like this is time along x-axis, this is x-axis, and this is time. In seconds, this is the speed, meter per second, that is this is y, this is x-axis. So initially graphs goes like this is one position, it attains the position, and graphs goes like this. And from this position graphs goes in a straight line. So now this is a little bit curved graph here. This is a curved graph from this point. This is point A and this is point B at 4 seconds, and this is point C. Let us connect it A and C. Okay, so this is one triangle we get. This triangle I just make a little bit shaded. This is the situation of this graph. So now what it is saying, the speed time graph of a motor car is given. This is speed time graph. Speed is on the y-axis as usual and time is on x-axis. How far does the car travels in first 4 seconds? This is the question. So this is the 4 second. At 4 second, after 4 second, so this is the speed it attains 6. So it is asking how far, I mean distance. So we already studied distance in speed time graph. Is the area under plotted graph line. So this is the area, this is the shaded area. Shaded area under the graph line is, okay, is this one A, B, C. We have taken A, B and C. I just connected C because this is negligible area. This area is very negligible. So I just considered AC directly, AC. ABC is the area, this is the one triangle. So this distance will be the area of this triangle, area of this triangle, area, because area under this graph line, AC, AC is the graph line under this shaded area is the triangle, area of triangle ABC is equal to half AB multiplied by BC. So that will become AB is this much of distance, which is 6 here, and BC is 4 second. This is 4. So that will become 24 by 2, and that is 12 centimeters. So this is the area, I mean this is the area of the triangle, and that is nothing but the distance. So like this we'll calculate the distance from the speed time graph. I mean the shaded area under the graph line is called the distance for the speed time graph. This is one explanation. Another one, which part of the graph represent the uniform motion of car? You just visualize from C to A, there is a change in the speed with respect to the time, but at the point A, you notice it down, this graph line is straight continuous horizontal line, and at this point, from this point to the further points, this line is straight and there is no change of the speed, which is fixed here, which is 6. So this part A onwards, after A, this part shows the uniform motion. Uniform motion. This is the uniform motion after A. So like this you can interpret the graph, you can understand the speed time graph, you can calculate the distance, which is the area under the plotted graph where you want to calculate the distance, and uniform motion you can show in the graph, which is the straight line parallel to the x-axis. So I hope you are now able to understand everything. So thank you very much for visiting COACHINGCARES.in. Watch free educational videos, get best quality study materials, study from the best tutors and mentors. Thank you once again.